Hi everyone. Thanks for showing up. Um, yeah. So as the title tells you, we are going to be talking about graph computing and databases. It is going to be introductory, so if you're already familiar, some of it may seem boring. However, I hope that everyone, irrespective of their experience, will take away something from this. If I'm inaudible or you don't get something, feel free to interrupt me. Okay. So about me briefly, I am Akash. I'm from New Delhi, India. I work at a company called Social Corps. We provide data products, data governance platform, primary data collection tool. I've been involved in open source for quite some time. Did a summer of code program at Google. And yeah, I'm a big PyData fan, and I've been using Python for quite a number of years, like all of you, I hope. So yes. Before we get into the nitty-gritties, let's just clear our whys. Why are we here? We are here because, first of all, graph is an elegant representation of data. It has been around for quite a while. Graph theory as a field has existed since the 1800s. And there's a lot of work to leverage upon, particularly in this age of data. And recently, we have seen a rise in the technologies and the solutions that are being provided, which leverage graphs as a data structure. So we'll touch upon all these points throughout the presentation. So again, now that the whys are sort of out of the way, let's talk about a bit about the what. So what exactly do I mean when I say graphs and graph tech? One term which you will hear throughout this presentation is graph tech. It's something that I came up with myself. You don't really hear it that often or read about it, but it's sort of an umbrella term which will help us get on the same page. So what graphs are, if you are not already aware, they are mathematically a set of vertices or nodes or entities and relationships between them. That's essentially what a graph is. And a graph tech solution, or graph tech in particular, is specifically software that's designed to leverage the graph data structure to help you solve problems. In our case, data intensive problems. And to further drive home my point about the utility of graphs, let's rewind to the birth of graph theory. Now, this is a pre-World War German town called Königsberg, and it had this peculiar geography where it had 4 land masses and 7 bridges connecting them. And the problem statement that came up back then was if you could cross all the land masses without crossing any bridge twice. And Euler, the great mathematician, was able to solve it by turning that A into B. Essentially, he took this complicated setup and converted into a bunch of points and relationships or edges between them. And what this basically highlights is, and it had to do with something called Eulerian path, which essentially also had to do with the number of edges which are incoming and outgoing from a node. So I'll let the mathematics be, but the point here is that even visually, it's much clearer to see it from A to B. And yeah, so this was basically the birth of graph theory. He called it geometry of positions, I believe, and yeah. So ever since then, a lot of work has been done, and things like shortest path algorithms, which you may have heard about. So yeah, and there's also the famous PageRank from Google, which again we'll talk about in a bit. So the last 2 talks here have been about Postgres and SQL and MySQL. So I love the tabular data format. That's what I'd started out with when I started doing data science, when I started working with data. I still do. And tabular format we have is sort of a de facto representation of data nowadays, has been for some time. And tabular format, although pretty good, and it has held us good for a long while, it's restrictive in a number of ways. Particularly, it's not in line with our mental model. We don't see things and we think tables, right? But a graph is something which is more intuitive. You can connect things in your head like a graph. You draw flowcharts. All those are intuitive representations of data. If you could work with your data in the same format as it is in your head, it will reduce the amount of stakeholders. It will reduce mediators. You won't have a business person talking with a technical person and 2-3 layers in between, and all the uh, knowledge getting lost and friction happening. To further sort of understand this, let's see a couple of concrete examples. Now, this deals with GTFS, which is a data format that was developed by Google back in 2007, I believe, or something around that. And it stands for General Transit Feed Specifications, and it provides a common format for representing transportation and transit data, public transport data. And there are um, municipalities and public civic bodies releasing their transit data throughout the world through APIs or in a static format in the GTFS specification. And it has a bunch of tables. It has stops, routes, trips, stop times, fare attributes, and it's a fairly good format. It's been around for more than a decade now. Um, However, and you can do a lot of things with it. You can do route planning, you can find central nodes, you can find the important routes once you convert it into GTFS. However, dealing with tables it can be a bit messy, particularly because you'll have to join things a lot. And if you are familiar with RDBMS or SQL, joins can be expensive. And for something like this in particular, with so many tables and so much such diversity, it can be a pain to work with SQL, particularly for more complex use cases. So if we were to convert this whole setup into a graph, so let's say we take 4-5 tables and we'll represent it in a graph like with a schema, something like that. We'll have stop time, trip, route. Trip uses route. We have a relationship called uses, and stop time is located at stop. And basically, you represent your data in this format. It's much more intuitive, and it helps you apply graph algorithms. It helps you do queries in a more intuitive way. Joins at runtime are not present anymore. So yeah, this is one example where where graph really lends itself very well to the problem statement as a data structure, and you can use it. However, since we are so ingrained and so used to using tabular data formats, it could happen that even if we realize that yes, this data by itself can be converted into a graph, we will still want to use an existing solution or other solutions other than graph tech, what I call graph tech, something like SQL. And rather than using a graph database or a graph processing framework, we will say we will represent this data as a graph in SQL, and we'll work with that. And that can throw up some problems. So this example is taken from a book called Designing Data Intensive Applications. It's an amazing book. And this data, if you can see it, can everyone see the data that's here? Is it visible? Okay. So basically what what is represented is, think of it as a social network, and you have a couple. They are of the types person. You can define types. They are basically properties of the node or the entity. And you have relationships. You have relationships which deal with their birthplace and as well as their current living information. So now one thing, if you could see this, you could notice is there's difference in granularity and regional structure. So France as a country has something called city, department, region, and country. And US has slightly different regional structure, and UK has again different regional structure. Representing it in a tabular format will cause you problems. For example, you can try representing it In Postgres, you have the JSON data type. You can probably store regional structure as JSON, but then again, that's sort of fitting your data into your existing solution rather than leveraging the solution as it is. So again, something like graph databases can come in. So one thing that you could do with this data is, let's say you wanted to represent it in SQL, in an SQL solution as a graph. So what you could do is you could create a table called edges, you could create a table called vertices, and then you could try to work with it. However, let's say you did that and you wanted to do something as simple as find the number of people who left their birthplace to go to another continent. And to do that, you will have to write a query as long as that. I don't know how many lines it is, but it's a good enough number that we'll not want to do that for something as simple as that. And if you were to use a graph database, this particularly and represent the graph in a graph database, essentially use GraphTech. You could use a query language called Cypher and a graph database called Neo4j, and you could do this same query in a couple of lines. And yeah, that sort of highlights the importance of graph tech to go along with the graph data structure. Yeah, so I hope everyone followed along so far. Okay, so now we know the what and we know the why. Let's see how exactly some real world cases are being realized using GraphTech. And this is something which has caught pace over the last few years, particularly since let's say Google brought this term called knowledge graph back in 2012 to augment its search technology. And knowledge graphs were probably, in my opinion, the biggest catalyst in recent times for the term, the idea itself, which catalyzed GraphTech and sped the whole development process and of the ecosystem. And what a knowledge graph basically is, it's your data represented in a graph format, but done smartly. It's smart and it's incremental. So if you have your organization and if you have data of any kind, or if you have your community's data, you can represent it in a graph. You can make it smarter by defining relationships in a way which is more closer to the world, the relationship names, for example, or you could put in certain constraints. You could put in, you could apply ML on top of it to make it for it to be able to predict links, for example, which don't exist. Those are the kind of things which Google already does and has helped them improve the search a lot. And LinkedIn or eBay or all these huge companies already have started leveraging and have been leveraging for some time knowledge graphs for their core tech. And then there are things like recommendation engines, social networks is an old example, is a very de facto example for usage of graphs and networks. And then you have some other examples, which if you simply search for the use cases, you will see a lot of them. However, I will dive deep into one particular use case, which is not that intuitive. However, it's really a smart way to show how graph tech can be leveraged to solve very, very fundamental and critical problems. So data democratization, if you are not aware, is a concept where you want your end users to be able to use your data, to use data with even non-specialists, even the folks who don't know data science or don't know how to work with data without the help of specialists. That's the concept. And Airbnb, at this time, this particular solution was implemented, which we'll get to in a bit, was already 3,500 plus people strong. They had more than 200,000 data tables in their warehouse. They had 6,000 dashboards and one very simple problem that they were dealing with was how to find the data. That basically was the problem statement. How to find the right data. Because the search engine itself was not able to, a simple search engine, something like like indexing using Elasticsearch, was not able to cut it. So what they did was they brought all that data together. So whether it was a warehouse, tables where it was the dashboards, they brought it all together. They processed it in Python. They created a graph out of it. So basically, think of a graph where you have information like this user created this table, and this table was used in these many dashboards. So you have this whole rich connection, and they put it into a graph database called Neo4j, and they built a whole UI on top of it and indexed that data. And what this essentially did was this allowed them to capture the information, the relationships that existed between all those tables, all those data sources, and that works much. It was like a knowledge graph of the metadata, and it helped them further their cause of data democratization. And yeah, so they use something called Airflow, which if you ever have worked with data processing pipelines, you will know. And they used the algorithm called PageRank, which Google itself uses. And they were able to improve their search results, basically find which are the more important data sources, which are being used a lot more, which connect to a lot of other data sources, and which are being worked upon by a lot of data users. Having your data in a graph format and being able to use an algorithm like this was a big plus for them. So now that we know the whys, the whats, the hows, let's go on a let's talk about a little story, a story of how graph tech has risen, as being talked about in this talk. So graph tech, in my opinion, or in general consensus, started really taking off when semantic web as a concept was brought up. And semantic web, how many of you are aware of the term semantic web, or at least vaguely heard of it? Yeah. So semantic web was a term coined by Tim Berners-Lee of World Wide Web. And it was supposed to be an extension to the existing World Wide Web, where you replace the web, where the web of pages were replaced by web of things, where essentially everything was an entity, and they were all connected with each other. That was supposed to promote data exchange and data interchange, and basically a more inclusive web. And one of the core concepts of semantic web was everything was represented as, or at least that was one way to implement it at that time. What was proposed was triples. Through triples. Triples basically is you have things in the form of subject, object, predicate, basically two entities and a relationship. And that's when a lot of solutions were implemented in order to help realize semantic web. That never really got realized, but all those technologies have lent themselves to the graph ecosystem really well. And in general, over the last few years, with the help of all the research and all the work done by a lot of people around the world, the graph ecosystem has risen. That includes the databases, processing frameworks, for example, things like frameworks like Spark. They natively have started supporting graph processing workloads and algorithms. And you have all kinds of beautiful visualization frameworks as well. And the third aspect of the story of the rise of graph tech is recently big cloud players have also started providing graph services as managed services on the cloud, and that again will help everyone get up to speed quickly, which has happened with a lot of technology recently. So we covered the whys, we covered the hows, the whats, and some of the story. And this is a fairly easy question to answer. But when do you use graph tech? When to use graphs as a data structure? And you use graphs whenever relationships are important. And relationships in general have started to become more and more important as our world becomes more interconnected. Things like IoT become prevalent. You don't like single tables won't really cut it. And existing solutions may not be as efficient as you want to do real time analytics and things like that. So the first point is these 2 points cover a lot of our real world use cases, and many to many relationships I put in there specifically because if you have again dealt with tables which have many to many relationships, they can be a real pain to work with, because you have to do multiple joins. The data can grow exponentially. You put in 200 by 100 rows, 2 tables with 100 rows together, and they'll quickly grow to a really large size. And so it's better to sort of transfer that from query time and doing that over and over again to creating a graph out of it. That's one very simple way to put it. However, when not to use them, you won't want to use them when you have disconnected data, when simply having data in the form of 3 different tables, a simple web CRUD application where you don't want to do a lot of where you don't want to deal with relationships, you don't have to. Forcing data into a graph model won't help you, so it's better to go with solutions such as SQL or probably NoSQL. The second point is something which, if you remember the example about the social network earlier, you had regions of different granularities. So that was sort of an example where the data model was not should be flexible. Let's say you add a new region, you add a new country, you don't want to redo your entire schema. So a graph database can allow you the flexibility. But if your data is not like that, again, you can consider going with the more conventional approach. And one last example. This is a bit more technical. So graph databases and a lot of graph computing frameworks in general, they work well when you know your starting point. And in very simple terms, they are not designed for bulk scans. That's something that a lot of index engines as well as a lot of RDBMS solutions are good at. However, graph databases, they are getting better at that, but they're not necessarily designed for that, a lot of them. So you can skip over if that's your problem statement. Challenges. So one big challenge, I think it's pretty obvious. If you want to work with graph tech and graph based solutions, you need to create the graph. So that's one of the big challenges that one faces, to create it. To create it can be a big problem, particularly when you have all that messy data. And let's say you will have to do things like deduplication, entity resolution, all those things in order to be able to create a really good graph. And that's something that I'm particularly very interested in. It's a great challenge, and a lot of research projects as well as companies have cropped up over the last few years. There are companies like Enigma. It's based in Europe itself, and of course, at my workplace also, we are in the process of building a knowledge graph platform. And second, and more, and a problem that you may have dealt with if you have ever worked with technology, which is not in a very mature phase, is that the ecosystem is still developing. It has not consolidated. It is not saturated. Even the available options, there's a lot of disparity. Standards by themselves are coming up. For example, there is an effort underway right now by multiple graph providers and multiple graph tech providers to come up with a single query language called GQL, which will be very much in line with SQL. And development of standards is always a good sign for any technology. And that's something I'm personally looking forward to. However, still, you can find yourself in potholes as you start working with graph tech. So now I will try to do something. I'll try to do a live demo for you guys. And let's see if the demo gods work with me. Okay. I hope everyone has, it's a fairly introductory session, so I hope that everyone has gotten what I've been trying to say so far. Okay, so this is the interface for a graph database called Neo4j. It's one of the more popular databases. It has its limitations as compared to other graph databases. However, it has good content and it has a good community if you're starting out in particular. So if you remember the GTFS example about the transit data, all those routes and stops and stop times, we'll try to. So I have already converted that data into a graph using a few queries which look like this. If you can see them. So essentially, you have your data in the form of CSV files, and you can programmatically or through the UI interface convert them into tables. You sort of do your joins at creation time itself. You create your relationships. This is a language called Cypher. If anyone wants to look into it, Neo4j has really good examples. And if you have no SQL, it's very close to it, in the at least from a mental perspective. And it uses ASCII art, so it looks good. So I've already created the graph, and let me show how it looks like. Oh, okay, no, sorry. I'll first show you how the graph looks like. So this is how it looks like. You have a root entity, a root node basically, and then you have something called trip. Now this will be constant throughout. You can find data, you can find code to convert GTFS data into a graph online. Europe, USA, Asia, all the transit system data that's released, most of it is in the same format. And yeah, so this is how it looks like. Much more convenient than a bunch of tables with foreign keys and a lot of constraints specified. So let's say I wanted to find the shortest path between couple of stations in Delhi, couple of bus stops. And Railway Museum is self-explanatory. Red Fort is a very popular landmark monument in New Delhi, India. So this is what you will get if you were to do this. Let me try to break this down. So again, I'll try to open source the code and put this out as a blog. However, in the short time, for you to understand what's happening is basically I had done a query which tried to find the shortest path from A to B, and what happened was there no direct route existed. So what I got back was a bunch of ways to get from A to B and an intermediary stop that was told to me by virtue of the structure of data being in a graph. And it was pretty fast. I didn't have to do a ton of joins. So what this basically tells me, just a lot of noise on here because it's the basic UI that's provided by Neo4j, but there are much more beautiful frameworks out there for you to be able to do this. But Railway Museum was my first stop. I wanted to go to Red Fort, and what I got to know through this is through a simple query that I will have to go through this one stop called Vivekanand Mark. Yeah. So these are the kind of things that you can do. Then you could also possibly apply a PageRank on this and get the stops which are important. Essentially the same technology that's used by Google to enhance its search results. And since I still have a bit of time, I'll quickly show you how you can do this through Python. Or at least I'll just show you that you can do something through Python itself. Um, so like a lot of other um, databases, Neo4j also provides a Python framework for you to be able to interact with it. There's the official driver, and then there's this more usable library Pythonio that's been developed by one of the core developers of Neo4j. And you can do things, you can almost do everything that you can do via the UI interface and the query. However, it has limitations when if you want to do some more complex queries, because how you can create a query, you can write it down and you can perform it. However, the ORM interface by itself, which basically means through the programming abstraction, there are still some chinks which need to be solved. So I'll simply import the graph module from Pythonio, which is the library. Then I'll simply, let's say I want to get information about the same stop, Railway Museum, from the graph. I can, oh, I converted into list. Wait. Oh yeah. I don't actually remember how to do that with this thing. I'll actually, once I run this, I'll try that. So what you get is the same information that you got through the UI interface. You can do things like this. Graph.nodes.match is the whole function. The match is the final function that you call, and the method that you call, and this is what you get. And yeah, so I think I put across my point, and I'm almost done. Yeah. So these are some resources that you can look at if you are interested and want to look more into this. You have a lot of great community content from Neo4j. Then Apache has a framework called Tinkerpock, which is a graph computing framework that works with a lot of databases, provides you with a single abstraction, so that you don't have to learn a new language or framework every time. NetworkX is a popular framework for manipulating and creating and processing graph data and graphs in Python. And I think there's a talk which deals with network and NetworkX at PyCon X itself today or tomorrow. And then you have a couple of other things. I'll share these on my Twitter handle. Yeah. If anyone wanted to click a pic or something. So I'll share this. And yeah, so if you want to contact me, I'm available on Twitter and mail. And if you want to follow my open source work, I'm on GitHub by the name Analytical Monk. And yeah, that's pretty much it. Thanks for being here. And if you have any questions, feel free to shoot. And if you didn't get anything in the talk itself, feel free to catch hold of me now or later. I'm around till Sunday. So thanks for showing up, and hope you look more into this. Thanks.
Thank you so much, Akash. It was very interesting. Any question? Yeah, one on the back.
Thank you for the talk. Can you please discuss what's a way to use Neo4j for natural language processing, please?
Okay, so yeah, that's something which I actually should have talked about. So graphs in general, or knowledge graphs in general, are used as a base often for natural language-based problem statements for basically creating natural NLP solutions. And for Neo4j in particular, it's something I have not personally worked with like a lot. However, there exist, so Neo4j has something called procedures, and particularly APOC procedures and procedures. These are community driven code modules, which almost work as good as native modules. So you have a lot of, so once you have your data in place, and if your relationships are defined well, and if your data structure is well, so depending on whatever you want to do, you can use procedures, like this particular procedure that you want to use with it. And you can search for it, and yeah. Anyone else? Anything?
Hello, thank you for your talk.
Hi.
And I just want to ask if I've done in the past some network analysis stuff, and back then it wasn't so simple to. Let me rephrase. It was more easier. It was easier to do network analysis stuff using a CSV file, loading the graph into memory, and then process, do computation and so forth. And in your experience, is it now possible to plug in Neo4j under this library like NetworkX or iGraph or something like this?
So if I get your question right, you basically want to know if it's easier now to work with networks and graphs in general, and particularly NLP solutions. You had problems fitting things in memory as well, that's what you're saying. So when was this? Which year? How long back? 2000?
It was 2012.
Okay, so trust me, yeah, even back in 2015, it wasn't that easy. However, in the last 2 years, a lot of work has been done. The community has grown, and if from 2012, at least I can guarantee you it's much, much easier. As for the in-memory part, Neo4j particularly still has some issues with that. However, they have introduced this thing called causal clustering, and they are trying to do all kinds of stuff. However, however, there are other solutions as well. There's this graph database called GraphX. dgraph, and then there are then Spark itself has started offering something called graph frames, and so it's developing really fast. And it's much better from 2012. I can definitely tell you that it's much easier. It has gotten much easier over the last 2 years itself. So from 2012, it will definitely be a big leap, and you can definitely try this. However, there would be times where you won't need specifically this. So probably better to think really hard. It depends on the use case to use case. There are still cases where the tabular format will be much easier to work with. Yeah, but particularly things like memory and processing, it's gotten much better.
Okay, but we are not yet there.
No, we are there. I think we are there. We'll reach that point very easily.
Okay, thank you.
Any other questions for Akash? Okay. Thank you. There's anything that you want to add?
So I actually want to add.
Sure.
Yeah, one last thing. It's not that we are not there yet. I actually don't know the use case which you particularly want to deal with. That's why I can't. We can talk about it later. So, but from 2012, it's almost like another world out there right now. So yeah.
Okay. So another round of applause for Akash.